So in circular lamina, so as we have discussed in the first class, so for circular lamina we doesn't have the edge as well as the corner. Okay, so it may rest on any one of the points on the rim of the your circle or the circular lamina. Okay, the circular lamina, once again I'll repeat it, a circular lamina so doesn't have either the corner or the edge. So it may rest on HPR, VPR on any one of the point on the circumference of the circle. So first we will discuss, so after drawing a circle, how to divide the circle into our required number of the points. So the circle put together, if we consider, it is having 360 degree, correct? So if you want to divide the circle into two equal parts, what you have to do? So we have to draw the 180 degree line passing through the center of the circle. After drawing a circle, if you want to divide the circle into two equal the parts, then we have to draw the 180 degree line passing through the center. Then as you can see here, so the circle I have drawn here, passing through the center, I have drawn one horizontal line. So it's a 180 degree line. So now I can say the circle is divided into two equal parts. Similarly, if I want to divide the circle into four equal parts, that is 360 by 4, how much? 90 degree. So in the next slide you can see here, so in this the example which I have taken here, the circle is divided into four equal parts. How to do it? 360 degree is the total angle of the circle. If you are dividing it by 4, 90 degree, that's what, along with the horizontal 180 degree, one more line you draw it, vertical line passing through the center. So then I can say, so it is the divided into four equal parts. So in our projection is concerned, the more the points we divide, the smooth curve what you will going to get at the last the position of your the projection of the circular lamina. So that's why we restrict our the number of points into 8 equal parts. So how to divide the circle into 8 equal parts? The circle can be divided into 8 equal parts by drawing 45 degree line passing through the center of the circle like this. So now how many points you are getting? 1, 2, 3, 4, 5, 6, 7, 8. So for our convenient, so I am dividing the circle into 8 equal parts. How to divide the circle into 8 equal parts? So 360 degree is the total angle of the circle. The 8 equal part divided by 8 means 45 degree. You will going to get 45 degree line if you draw passing through the center. So you can able to divide the circle into 8 equal parts. So I hope all of you understood how to divide the circle into our required equal number of parts. Even you can divide the circle into 12 equal parts also. So 12 equal parts means 360 by 12 means 30 degree you can take and you can divide. As I told, we'll restrict our into 8 equal parts. The more the number of points you divide, the more the smooth curve you will going to get for the final shape of your the circular lamina. So with this basics, let me start. Today we'll discuss only two examples so that you can practice today. So next class we'll discuss two more example. The first example it is shown here. So I'll read it first, then we'll have a discussion. So here it is given, draw the projection of a circular plate of negligible thickness of 50 millimeter diameter resting on HP on a point on the circumference with its plane inclined at 35 degree to HP and the top view of the diameter. It is not top view of the diameter passing through the resting point makes 60 degree with respect to VP as given. The first sentence what it gives, a circular lamina is there and the diameter of the circular lamina is 50 millimeter and is clearly he mentions that it is resting on HP on one of its the point. Any one of the point on the circumference, it says. Okay, so here what you can do is the first you draw a that means he says it is resting on any one of the point. Yes, specifically given point A. Okay, it's resting on HP means where you have to draw the true shape diagram. So you have to draw the true shape diagram on HP, that is nothing but top view. You draw a circle of radius the 25 millimeters, so that the diameter of the circle you have to get 50. From the center of the any point, you take any one of the point as the center and draw the circle of the 25 millimeter diameter or the 25 millimeter radius or the 50 millimeter diameter, and divide the circle as I given the instruction at the beginning. So you take 8 equal parts. So that means you have to draw the 45-degree line, draw one horizontal line, vertical line, and then from here you take 45-degree passing through the center. You can draw one more line, and this line from this vertical line you can take on 45-degree line, and you can draw it. Okay, so like this, so you can divide the circle into some equal, that is 8 equal number of points. After that you name it whichever the fashion you want. So I have taken A, B, C, D, E, F, G, H, total 8 points. This completes your the top view like this. So I hope all of you understood this. So after this, to draw the front view, so you have to draw the vertical projector from all the points like this, from A, B, C, D and E like this till it meets the XY line, and then afterwards you join it with a thick line. So your front view is ready, and also you are looking from the front side. So A, H, G, F, E you can see, but you cannot see B, C, D. The points that you cannot see, you have to put it within the bracket like this. This completes your the front view as it is shown here. So now the second sentence what he has given. So the lamina is inclined at how much he has given? The circumference of the plane is inclined at 45-degree to HP as given. So what I have to do? You take any one point on the right side, the same XY line. From this point, you can draw a 45-degree line. You can draw a 45-degree line from this like this. After drawing a 45-degree line, with the help of your compass, you take this front view length and this as the center. You cut this 45-degree line. After cutting this, you join this with a thick line and transfer all the corresponding points also here without changing anything. From A to this point, you cut an arc and name it H dash and B dash, and from here to this point you can take and you can mark it like this without changing anything. You have to transfer all your points, you can transfer it like this. So this you are familiar with this, so you can able to draw this. So this completes your the front view. Now to draw the top view, what you have to do? So you have to draw the vertical projectors from this front view which you have drawn now. Draw the vertical projector from all the 5 points you will be going to get like this, and draw the horizontal projectors from this top view, the true shape top view like this. Now you coincide the points and name it. So A is here and A dash, this is A dash. B is B dash, this is B. C is here, C dash is here, this is C. D, D dash, this is D. E, E dash, this is E. F, F dash, this is F. G, G dash, this is G. And H, H dash, this is H. So in circular lamina, you remember this. So in the second position, if the lamina is inclined to any angle with respect to either HP or VP, it looks like an ellipse. So this is the apparent shape of the circular lamina, whatever you have drawn here. Okay, so this is called as the ellipse. It has got the major axis. This is major axis, which is equal to the diameter of the circle, and this AE is your minor axis. CG is your major axis and AE is your minor axis. So this after naming this point A to H, you need to join these points with a smooth curve. You have to join these points with a smooth curve with your free hand only. But whereas in the software, so directly you can draw a ellipse and you can place it here. So that is the only change. So till here, I hope you have understood. So how to draw the top view, that is the apparent shape of circle is nothing but it's an ellipse. So now the next question, the next sentence, what it says, the top view of the circumference, that is diameter. So which is the circumference as a diameter top view? AE. So in this case, so yes, clearly indicated in this the last sentence of the question, the top view of the diameter passing through the resting point. So which is the point which is resting? A. The top view of the diameter. So which is the top view of the diameter? AE. Passing through the point makes 60 degree with respect to VP. That means the information which he has given in this. So here it is directly he has given the apparent inclination. It is not the true inclination. So he has given the apparent. He has given the apparent inclination directly. He has given. So that's why what you can do it. So you can take 60 degree with respect to HP below XY line. Any direction you can take. I have taken here 60 degree. Without taking locus, we can draw this. So because since he has given the top view of the diameter passing through the resting point, make 60 degree with respect to VP. So beta angle apparent inclination directly has given. This is not the true inclination. So that's why I'll draw the 60 degree line like this. Then I'll take any one of the point. So I'll call one point as the E. What I have to do is I have to redraw this, the apparent shape of the circle, that is ellipse, such that the top view of the diameter, that is AE, should come on this 60 degree line. So this is what you have to do it. So E I have taken here. With the help of compass, you take A to E distance, you take and cut it on the 60 degree line. So A to E is ready for you. Okay. So to get the remaining 6 points, either you can go for the box method, you can go for, or even you can go for the arc method also. The box method, let me teach you. AE, you know, A to this line, you take the distance. This is the center, you cut it here. Okay, this point. From this point, you draw a perpendicular line or 90 degree line. You can draw from here. So after that, from this point to C and from this point to G, distance is same. So from this point, you cut an arc, that 90 degree line, and from this point, you cut an arc. So you get C and G point you can get. So after this, similarly, A to this line distance you can take, and E to this distance you can take, and you can draw a 90 degree line, perpendicular line to this AE. Similarly, from here to D and from here to F, from this point to H and from this point to B, all the distances are same. So from this point you cut it on either side, from this point you cut it on either side, you will get all other points. Once all other points is mentioned here, now without changing thing, what you have done here, similarly with your free hand, draw the smooth curve so that the same ellipse you can draw it here. So this completes your, and even arc method also you can go for the equidistance from any arc you can take and you can cut. So next, to get the final front view, you have to draw the vertical projectors from all the points. Total 8 points you will get. All the 8 points you can draw the vertical projector like this, and draw the horizontal projectors from all the points, the front view point. Now we coincide the points. So A dash, this is A dash, B dash, this is B dash, C dash, this is C dash, D dash, this is D dash, E dash, this is E dash, F dash, this is F dash, G dash, this is G dash, H dash, this is H dash. Now with the help of your free hand only, try to join all these 8 points with a smooth curve. You will going to get an apparent shape of your the circular lamina, which is not a perfect ellipse. You will going to get apparent shape of your circular lamina in this way. So this completes the projection. So now it is open for the discussion. Let me, okay, anything it is there, so you can send me a message in the chat so that I can answer, or separately also you can. Let me check. First circle, you want me to do it again? Okay. Anything else so that together I can address the issue? First circle, do it again. Okay, I'll do it. Anything else other than this so that I can address it? Can you explain the arc method for third step? Okay, that also will do it. Next. Okay. So how to draw the first circle? So you draw the, because since he has given it is resting on HP, so that is in top you have to draw the true shape diagram. Below the XY line, you draw a circle of radius 25 millimeter or diameter 50 millimeter. So we have to divide the circle into 8 equal parts. Okay. First you draw the horizontal line passing through the center. So then it is divided into 2 equal parts. Draw the vertical line like this passing through the center. Now it is divided into 4 equal parts. Now you draw 45-degree line passing through the center from here like this, and from here also 45-degree line like this. So these lines should be as light as possible. Okay, only the circle is your the object. So okay, these lines should be as light as possible. It should not be visible. Okay, you should not make it thick. So now you can name this. I did total 8 points: A, B, C, D, E, F, G, H. So like this. So you have to draw the circle. I hope so. It is clear, Surya. Next, Sushmita, she has asked how to draw this by arc method. So you know, first E you have fixed here, E to A you have taken, and the same 60-degree line you have taken this A. A is done. Okay. Then from A to C and A to G, E to G and E to C distance is same. So take anyone this distance. A as the center, you cut an arc. So A as the center, other side you cut an arc. Similarly, from E as the center, you cut an arc, and E as the center here, cut an arc. Wherever these two arcs coincide, you call that as the C and G. That's all. Okay. So after that, A to D and A to F is same, and E to B, E to H is same. You take any that is distance, cut an arc here and cut an arc here. E from E, cut an arc this side and cut an arc this side. Now C to B, C to D, G to F and G to H is same. So from here you cut an arc, from C cut an arc, from G you cut an arc here, and from G cut an arc here. Wherever these arcs intersect, you are going to get other 4 points. Now as usual you can join those identified points and your ellipse is ready. So I hope both the issues have solved. So still, is there any issues so that I can sort it out from anyone? Let me check. So anything else? Can we proceed to the one more example that we're going to discuss today? Yes? Okay, fine. So now the same example we'll discuss, so without changing anything. So in the first example, so here the top of the your the point joining, that is a circumference point, that is diameter point, he has given the apparent inclination directly beta. So in this example, so we'll discuss if the true angle is given, that is phi is given, how to complete this example. Okay, that means we have to take the locus. That's all. That I'll going to teach now. So the second example here, it is a circular lamina of 50 millimeter diameter rests on HP such that one of its diameters is inclined at 30 degree to VP and 45 degree to HP, draw its front view and top view in this position. So in the first sentence what he has given, a circular lamina 50 mm diameter rests on HP as given. So as I told, for circular lamina, you don't have a corner or edge condition. It may rest on any one of the point on the circumference. So what I will do, so true shape diagram, since it is resting on HP, the true shape diagram has to be drawn on top view, that is HP. So you draw a circle similar to the previous example of 25 millimeter radius or 50 millimeter diameter and divide the circle into 8 equal parts by drawing 45-degree angle. So for this, first by passing through the center, you draw an horizontal line. You can divide the circle into 2 equal parts. Once again, you draw the vertical line passing through the center. Now it is divided into 4 equal parts. Now from here, you can take 45-degree line, 45-degree, and you can draw a line passing through the center. And here also you can take 45-degree and draw a line passing through the center. So you can divide the circle into 8 equal parts. After dividing it, name it in any fashion, A, B, C, D, E, F, G, H are taken. So this completes your the top view. Now to draw the front view, this is almost similar to the previous one. Draw the vertical projectors from all the points like this till it meets the XY line and join this with a thick line. And how to identify the points? You are looking from front side, A, H, G, F, E you can see, but you cannot see B, C and D. The point that you cannot see, put it in a bracket. That's all. So this completes your front view, almost similar to the previous one. Till the second position, it is similar to the previous one. Only the last position I will teach you how to draw it. Now he says the diameter of the lamina is 45-degree to HP. So why HP inclination first we are considering? Because it is resting on HP. So let me take any one point here. I'll call that as the A dash point and draw the 45-degree line to some length. After that, I'll take this front view length A dash and E dash, this as the center. I'll cut it and call that as the E dash. I'll join this with a thick line. So this is my front. So I have, without changing anything, this front view, I have redrawn it on the 45-degree line. So now, without changing the point, from here to here, I'll take this distance and cut it here. That is H dash, B dash. From A dash to G dash, I'll take this distance with the compass. I'll cut it here and call that as the G dash, C dash. Similarly, A dash to this F dash I'll take from here, I'll cut it here and I'll mark that as the F dash and D dash. So like this, without changing is the length as well as the all the points I have transferred here. So this completes your front view. Now to draw the top view, draw the vertical projectors from all the 5 points of your front view like this and draw the horizontal projectors from all the 5 points, 5 line like this you will going to get. Now you coincide the points as usual. A dash is here, this is A, B is here, B dash is here, this is B, C is here, C dash is here, this is C, D is here, D dash is here, this is D, E dash, this is E, F dash, this is F, G and G dash, this is G, H and H dash, this is H. Now also with your free hand, join all these 8 points with a smooth curve so that it look like an ellipse. As I told, the second position in any circular lamina, it looks like an ellipse of major and minor axis. CG is your major axis, which is equal to your circle diameter itself, and A is your minor axis, which depends upon the inclination of the lamina. So you can get this ellipse like this in the top view. The third position, so he has given, so what he has given in the question, so he has given the true inclination only. The diameter of the circle inclined at 45-degree to HP and 30-degree to VP as given. So that means here the 30-degree with respect to VP is also a true length only, true inclination only. So that's why what I have to do is, so 3-4 examples we have discussed this type, like in square lamina we have discussed an example, and a pentagon lamina perpendicular bisector an example we have discussed, and yesterday's class in pentagon lamina one example we have discussed. Similar to that, so we have to do it here. So first you draw a 30-degree line in any direction below the XY line with respect to VP. This line, which you can see the cursor where I am moving here. So this is the true inclination phi. 30-degree line, you draw it first. I'll take any one of the point. I'll take that as the A point here on this 30-degree line. Anywhere you can take. Now the true inclination should come on the true length, right? So that's why I'll take the true length of this diameter. That is only the true length of the diameter I can get only in my true shape. That is AE, initial shape. Circle diameter is nothing but my true length. From A as the center, you cut the 30-degree line like this. Wherever it cuts the 30-degree line, you draw the locus line, horizontal line passing through that the section. This is your locus line. Now apparent length, which is the apparent length? The ellipse whatever you have drawn. So this is your apparent length AE in the previous top view. You take this AE with the help of your compass. With the same center A, you cut the locus line, that is the horizontal line you can cut here. You call this as the E. Now once it cuts here, join this line. And if we extend this line till it meets the XY line, so it becomes beta. So this is your apparent inclination. So all of you understood till here how to get this the apparent the inclination. Once you get this AE, the rest of the things it is similar. That means you have to redraw this ellipse such that this AE, that is minor axis of the your ellipse, should coincide on this AE. You have to redraw it like this. How to redraw it? As I told, you can use box method or the arc method. Any method you can use to redraw it. AE is fixed. Box method, from A to this distance you draw a 90-degree line. And that 90-degree line, you take this C distance from here to G distance, you cut it, and the 90-degree line C and G you will going to get. Similarly, from A to this distance you take, and E to this distance, from here you can see, draw a perpendicular line, 90-degree line here. Okay, and this 90-degree line from here to B, from here to D, from here to H, and from here to F distances are same. You take any one of the distance, you cut it on all the sides. From here you can cut here, so you're going to get an all 8 points. If you are going for the arc method, same thing, from A to C distance, E to C distance, A to G and E to G distances are same. So you can cut an arc from here to here, here to here, from E to the here and E to here. You're going to get C and G. Similarly, you can use this distance arc, and from here to here, and from here to here, here to here, and C to B, C to D, you're going to get other 4 points. So like this, you have to redraw this without changing anything, such that this minor axis of the diameter, that is AE, should come on this line. Like this, you have to redraw it. So only here you have to pay attention. Okay, the remaining thing, rest of the things it is same only. Now to draw the final front view, as usual, draw the vertical projectors from all the 8 points of the top view like this, and draw the horizontal projectors from all the 5 points like this. Now coincide the points. A is here, A dash is here, A dash you're going to get on the XY line. B dash, this is B dash, C dash, this is C dash, D dash, this is D dash, E dash, this is E dash, F dash, this is F dash, G dash, this is G dash, H dash, this is H dash. Like this, once you get all the 8 points, draw a smooth curve by joining all the points one by one, so that it can take this shape like this. For this, little practice is required. First you draw a light line, then after that you can overwrite on that to make it thick. So like this you have to complete. So any doubts in this example, just let me know so that I can clarify here yourself. So anything is required, just send me a message. Look into it. So today itself these two examples you completed and keep it ready, and any doubt is there, so you can contact me at any time. Tomorrow two more the examples we'll discuss. So I will ask you when you have to submit all 6 examples of your the hexagon and 2 plus 2 4 examples together. So in the edit I'll tell you tomorrow. Can you explain the third step again? Okay. Sorry, could you repeat on how we can draw the ellipse effectively? So third step, just AL and TL. Okay, AL is nothing but a pair. I'll explain from the third step. Okay, till here all of you understood now? So since in the third step, he has given the inclination 30 degrees to VP, it is the true inclination, it is not the apparent inclination. So that's why the true inclination is given, true length only should come on that, correct? So that's why after drawing 30-degree line like this from any point, the true length of the diameter, this is TL means nothing but true length. In the true shape diagram, that is circle only I can get. Apparent length of the diameter in the ellipse only I can get. This is the apparent shape of your the circle. So this AE is your apparent length and this AE is your true length. That's all. So that's why you take the true length, that is the diameter of the circle, that is 50 millimeter from A. Any one of the point you can take, call that as the A, and cut 30-degree line. After cutting 30-degree line, you draw a locus line, horizontal line passing through that intersection. Now, after drawing the locus line, you take the apparent length of the diameter of the circle, that is minor axis of the ellipse. This AE, this is apparent length. With the same center A, you cut this horizontal line or the locus line you cut and join this. So this is your AE. Once you get this AE, you have to redraw this ellipse such that this minor axis of the ellipse AE should exactly coincide with this AE or lies on this AE. Like this, you have to redraw it here. For this, so what I have told, either box method or the arc method you can go for. AE you know here, A and E. From arc method, let me explain first. A to C, E to C, A to G and E to G distance is same. So that, so A I can draw arc. From A I can draw an arc. From E I can draw an arc on all the two sides. So after this, so I can get this 4 point. Next, here also I can take the arc, I can cut it C and G I can get. So whichever the common distance is there from the arc method, you can take your own method, you can use. Box method, why I will always suggest means, so accurately you will get, because if you draw a perpendicular line, for example, box method, A to this distance you take here, draw a 90-degree line, and this 90-degree line you take this distance and cut it on either side. Immediately you will get C and G. Similarly, A to this distance, E to this distance is same. From here you take this, from here you take this. So E to this distance and A to this distance you take. Draw a 90-degree line, perpendicular line passing through that. So this 4 distances are same. From here you cut an arc like this. From here you can cut an arc. So like this, in any method you can go ahead with that and you can get it. Like this you have to redraw with a smooth curve, in the sense while joining it. So you have to join so that it look like an ellipse. So does any doubt? You can put it in chat. Locus line, somebody has asked. Just for locus line, you take any one of the point, you call that on 30-degree line, you draw, you take that as the A point. The true length you take, this is your true length, correct? A to E, the true shape diagram. This as the center, you cut an arc on this 30-degree line. Wherever that arc cuts the 30-degree line, you draw a horizontal line. So this horizontal line itself is your locus line. Okay. After that, you take this apparent length of the diameter with the same the point A. You can cut it here. So on the locus line. So this is your A. That's all. Still any doubt is there? So I hope you understood, and even the explanation also side by side I have given in the PPT. Go through it while drawing it. Still, if you got any doubt, okay, you can feel free to contact me and complete these two exercises today itself, so that we can complete tomorrow. 26th problem, second step. 26th. That is hexagon lamina, no? So you do one thing. So separately you send me a message. So I'll address that. Okay, hexagon lamina. Okay, then thank you. So any issues are there? So today itself, both the two exercises you completed. Any issues are there? So you can contact me. Okay. Thank you.